All right. So here we have this, okay? This is, by the way, this is going to have a y equation and a torque equation. It's not going to have an x equation. The reason for that is that none of these forces are in the x direction. This force is either up or down, and this force is either up or down, and gravity is straight up or down. Nothing is at an angle, in other words, okay? So this will just be simply y and torque, and it's, it's a little bit easier, okay? So the first thing you want to do, the first thing I think is to draw arrows representing the forces. Okay, so here's F1. Notice that F1 is at 0 from the left side. Okay, so it's right on the left side. F2 is 4 meters from the left side, right? So that's at 4 meters. All right. And then we've got the weight of the beam, right? So then the question is, where does the weight of the beam act? And this is the key concept here. The weight of the beam acts at the center. Okay, so we say that this force of 45 times 9.8. Okay, so when I say G, I mean 9.81, right? Okay, that force of 45G is at, well, it's 6 meters long, so this thing is at 3 meters from the left side. All right, let's see. And then the person is standing a half a meter from the right side, so therefore if we do from the left side, this force of gravity acting on this person, this 64 times 9.8, right, that I'm just representing as 64G, G is 9.81, okay, that force is at 5.5 meters from the left side, okay. Now I could do it all of these from the center and pivot this thing about the center, but really what I want to do is when I set up the torque, I want to set it up either torquing about this spot or this spot. Okay, either one works just fine. Okay, I'm going to pick the left side because that's sort of an easier thing for me to do than to figure out all of these. Okay, so there we go. Okay, so the first thing I'm going to do is I'm going to set up my y expression. So let's set up our y equation here. Okay, my y equation is F1 minus 45G plus F2. I'm just going left to right. F1 is up. I'm guessing that it's up. It might be down. Okay, but F1 I'm guessing is up, right? Plus F2, and then minus 64G is 0. Okay, so this is just translational equilibrium. We've got a force up, F1. We've got gravity is down. And this is, when I write this, I mean that to be 9.81. Okay, I'm not saying grams. That's 45 times 9.81. Okay, then F2 I'm going to guess is up. I always guess that they're up and let the math let me show that they're down. And then this is the force of gravity on this person, right? If we add up all the forces in the y direction, they add to 0. Okay, and then I'm going to set up a torque expression. Okay, so let's torque about the left side. Okay, we're going to torque about the very left side. So you always have to pick a point. You can't just talk about general torque. Okay, you got to pick a spot. So I'm picking this spot to torque about. Okay, remember clockwise is positive, anti-clockwise is negative. You can of course set it up the other way. It just really doesn't matter. You can even say clockwise equals anti-clockwise. It doesn't, but in general, there's 0 net torque about this point because it's not accelerating in any way, right? So okay, so remember torque is RF, right? So R is 0 for F1 times F1. Okay, and then this is of course how we're going to get rid of one of the variables in the expression. This has two unknowns and one equation. We can't solve it, right? This one though is going to have only one unknown because we got rid of it by picking a spot right where it acts. Okay, and then let's see, my next force is this guy, right? So that's going to be a clockwise torque. So plus 3 times 45G. Okay, minus 4 times F2. All right, so I'm just going radius times force, radius times force, radius times force, right? And then plus 5.5, is that right? He's a half a meter from the right side. So if it's 6 meters long, he's 5.5 from that side. So 5 0.5 times, that's a 5 times 64g equals 0. Now, because I picked this spot to torque about, F1 drops out of this expression, and I can now solve this for F2. Okay? So let me do that now. I'm going to just add these guys up. So 3 times 45 times 9.81 plus 5.5 times 64 times 9.81 is that, and I think I just divide by 4. 1194.36. Ta-da! Yay! All right. So now, now the question is, oh, and the fact that it's positive means that it's up. Okay. All right. Okay. So now let's solve this guy here. Okay. So let's see. I think I need a line of demarcation. All right. So let's just solve. Let's set this guy up. So I'm going to go F1 minus 45g. Plus, and then F2 I know is 1194.36, right? So I'm going to substitute 1194.3675, that's what it is, right? Minus 64g, and again, these g's are 9.81, right? Equals 0. Okay. So again, you take this number, we've solved for F2, plug it in for this guy, right? So that's the next step, right? And they all work out this way. Okay, so here we go. So now let's see, I guess I'm going to go 45 times 9.81 plus 64 times 9.81. And then I'm just going to subtract that guy, the 1194. And I get negative 125.0775. Okay, so F1 equals 1190. Whoa. F1 is equal to negative 125.0775 newtons. Okay, the fact that it's negative means that it's down, right? So I would say F1 is 125 newtons down. And that's what you'll want to write on the test. There it is. So interestingly enough, if you didn't have F1, this beam would tip over, right? The F1 is pulling it down. It's a bit like a diving board or something like that, right? He has got enough weight, then he's standing far enough to the right that he's actually making this force, instead of being up, is actually down, right? And then any amount that's down, of course, adds to the upward force that this guy has to exert. Okay, so again, your steps are draw arrows and figure out where they act, relative maybe to the left side or the right side or something like that, right? But okay, so pick your pivot point early and decide where they act. This is 0. The center, the beam's gravity of the beam, right, acts at the center. Okay, so it's 3 meters from the left side. That's because the beam is 6 meters long, right? It's going to be 3 meters from there. Okay. And then other given forces act where they say they act. This one's 4 meters from the left side. This guy is half a meter from the right side, so he's 5.5 from the left, right? And then set up your y expression, set up your torque expression. Set up the, when you do your torque expression, torque about a point where one of the forces acts, okay? And then that will eliminate that variable and you can solve that one. When you get that answer, plug it into your y expression and solve for the other unknown. This is the way they always work, okay?